You trust your memory more than almost anything else you own. More than your house, more than your savings, more than your own reflection. You trust that the person you were yesterday actually existed, that the laugh you remember from your childhood kitchen really happened, that the voice of someone you loved is still in there somewhere, stored, safe, retrievable. You trust that civilization itself is a kind of record. That history happened and was written down. That somewhere, somehow, the universe allowed something to remember it. But memory is not magic. Memory is not a soul floating free of consequence. Memory is matter, arranged in a fragile pattern, and physics has a name for what eventually happens to fragile patterns. Tonight we're going to look at that name directly. Get comfortable, and if this is your first time here, go ahead and subscribe to Navarium, because tonight we are not asking whether the universe has a soul. We are asking something colder than that. We are asking whether everything the universe ever remembered through us, every face, every equation, every grave, every song, is destined to disappear. Here is the idea, stated plainly. Before we take it apart piece by piece, we may be the universe's temporary memory, not because the universe planned us, not because consciousness was promised to anyone, anywhere, by anything, but because for one brief stretch of cosmic time, star-born matter arranged itself into brains, into language, into photographs and equations and telescopes and gravestones and half-remembered songs and the questions you ask yourself at 3 a.m. when you can't sleep. And every single one of those records exists in direct defiance of a universal pressure that is, slowly and without malice, working to erase them. Start small. Start with something that feels like it could never be taken from you. Think of a room from your childhood. Maybe it's not even a room you remember clearly anymore, just fragments. The color of a wall, the particular slant of afternoon light through a window at 4 o'clock. A sound from somewhere else in the house, a parent's voice, low and indistinct, carrying through a door that was never quite closed all the way. Maybe there's a smell attached to it too. Rain on hot pavement, bread, the inside of a coat that belonged to someone who isn't around anymore. These memories feel like they belong to you in some absolute sense, like proof, like evidence that a version of you existed once, in a particular place, at a particular hour, and that the universe took note. It didn't, not in the way you think. What you are calling a memory is, physically speaking, an arrangement. A configuration of neurons that fired together so many times that the connection between them strengthened, the way a path through tall grass becomes a trail the more often someone walks it. There is no separate compartment in your skull labeled childhood kitchen, where the scene sits, intact, waiting to be replayed like a film reel. There is only a pattern of cells, held in a particular relationship to one another by proteins and electrical charge. A structure that has to be actively maintained, the way a sandcastle has to be actively defended against the tide. And here is the part that should unsettle you a little. That structure is not protected from anything. It is not exempt from the laws that govern everything else in the universe, from stars to soup. The same physics that breaks down a fallen tree, that dims a photograph left in sunlight, that erodes a name carved into stone, applies, without exception, without sentiment, to the 3 pounds of electrified tissue inside your head. Your most treasured memory and a fallen leaf are, in the most basic physical sense, playing by the same rules. Now widen the frame. The atoms that make up your body, the calcium holding your skeleton together, the iron carrying oxygen through your blood, the oxygen itself filling your lungs right now as you listen to this, the carbon forming the backbone of every neuron involved in that childhood memory. None of it originated here. None of it was made on Earth. Every one of those atoms was forged inside a star, in conditions so extreme they're difficult to even describe honestly. Pressures and temperatures that fused lighter elements into heavier ones over millions of years, and then, when certain stars reached the end of their lives, scattered those elements across space in explosions bright enough to briefly outshine entire galaxies. That material drifted for an unimaginable stretch of time. It collected into clouds, and the clouds collapsed into new stars and the leftover debris around them, and on at least one of those leftover scraps of debris, the conditions were just right, for just long enough. For some of that stardust to organize itself into something genuinely strange. Something that could fold in on itself and ask what it was made of. This part you may have heard before. We are made of star stuff. People love to say it, and it's true, and it's beautiful, and it's also, on its own, an incomplete sentence. Because rocks are made of star stuff too. Asteroids are made of star stuff. A handful of cold gravel on the surface of the moon is made of exactly the same primordial material as the inside of your skull, and the gravel does not remember anything. What makes you different from the gravel is not the atoms. It's what the atoms learned to do. At some point, under conditions that remain genuinely rare even across the unimaginable scale of the universe, matter didn't just clump and orbit and erode. It began to record. Not in some mystical sense, but in a literal, physical, measurable sense. A structure formed that could be altered by an event, and could hold that alteration, and could later have that alteration influence its future behavior. A scratch that changes what happens next. That is, at the most basic level, what a memory is. Not a movie playing in a private theater inside your head. A scratch. A change in physical structure left behind by something that happened, still influencing the system long after the original event is gone. The universe didn't just make stars and rocks and weather systems. Under rare and specific conditions, it made matter that could keep score. This is where we need to be careful, because it would be easy and tempting to slide this idea into something warmer and more comforting than it actually is. So let's say clearly what this is not. This is not a claim that the universe is conscious. It is not a claim that the cosmos has a mind or intentions, or that physics has somehow proven we were meant to exist. There is no evidence for any of that, and we're not going to pretend otherwise just because the alternative is harder to sit with. What we can say, carefully, is this. The universe, through entirely physical, entirely describable processes, produced systems capable of storing information about itself. Brains do it, holding patterns shaped by experience. DNA does it. Carrying a kind of compressed record of billions of years of evolutionary trial and error, every successful adaptation a faint signature written into a molecule. Fossils do it, holding the rough shape of creatures that died millions of years before anything capable of language existed to name them. Ice cores, drilled out of glaciers, do it too, holding bubbles of ancient air that tell us what the atmosphere was breathing long before there were lungs around to breathe it. Even light itself becomes a kind of memory. The light hitting a telescope's mirror tonight may have left its source before multicellular life existed on Earth. A telescope pointed at the right patch of sky is, in a very real sense, reading a message that's been in transit longer than complex life has been here to receive it. And then there's a civilization's layering memory on top of memory. Books, carvings, songs passed mouth to mouth before anyone thought to write them down. Mathematics which somehow manages to encode patterns true everywhere, independent of who's doing the counting. Monuments built specifically so that someone, someday, would look at them and remember that something mattered here. Servers humming in climate-controlled rooms, holding more raw information than every library in human history combined. Every single one of these is memory in the broad, physical sense. A pattern held in matter or energy that persists past the moment that created it, and continues to do something, influence something, mean something, because it persists. But here's the catch, and it's the catch this entire video is built around. Every form of memory costs energy, and every form of memory is fighting a current that never stops pushing the other way. Let's go back to the brain for a moment, because I think this is where the idea lands hardest, closest to home. It's tempting to think of your memories as things you possess, the way you possess a photograph in a drawer, fixed, waiting, unchanging until you choose to look at them again. But that's not what's happening in there. Memory in the brain isn't a ghost, isn't a file sitting in storage waiting to be opened. It is an active, ongoing, metabolically expensive process. Synapses, the junctions where neurons pass signals to each other, physically strengthen or weaken depending on use. Proteins are built and broken down to stabilize certain connections. Blood flow delivers oxygen and glucose to keep the whole electrochemical machine running every second without pause for as long as you're alive. If that maintenance stops, even briefly, the pattern doesn't just sit there waiting patiently to resume. It degrades. Ask anyone who has watched a person they love lose themselves slowly to a disease that erodes the brain's physical structure. The person doesn't lose their memories the way you'd lose a book. Misplaced but theoretically still existing somewhere, intact on a shelf. They lose them the way a sandcastle loses its shape to the tide. Gradually. Then, all at once, the structure itself is going. There's no vault underneath it where the real memories are being kept safe. And it isn't only true for memory loss and illness. It's true for ordinary forgetting too. The kind that happens to all of us, quietly, every day. A face you used to know perfectly starts to blur at the edges. A voice you could once recognize instantly becomes harder to hear clearly in your mind. This is not a malfunction. This is the baseline behavior of the system. Maintenance against decay is the price of admission for having memory at all, and the moment you stop paying it, decay simply resumes its natural course. Here's a way to say it that I think gets at something important. You are not a thing that has memories, stored neatly inside you like coins in a jar. You are, in a very real sense, a memory maintaining itself. An active process, not a static object. A flame, not a photograph of a flame. And flames require fuel. This brings us to the concept that's going to sit underneath everything else we talk about tonight. Entropy. People throw this word around casually, usually to mean something like mess or chaos, a teenager's bedroom, a desk covered in papers. That's not wrong exactly, but it's a shallow version of a much deeper and stranger idea. In the language of physics, entropy describes the tendency of energy to spread out, of differences to flatten, of structured, usable arrangements to drift, over time, toward less structured, less usable ones. It's not a force pushing things apart. It's closer to a statistical inevitability. There are vastly more ways for a system to be disordered than there are for it to be ordered. And so, left alone, systems drift toward disorder simply because disorder is so much more statistically likely. You've felt this your whole life without naming it. An egg, dropped, doesn't reassemble itself off the floor and leap backward into your hand. Smoke from a candle doesn't gather itself back into the wick. A hot cup of coffee left on a table doesn't spontaneously get hotter while the room around it cools to compensate. Energy spreads. Heat flows from hot to cold, never the other way, not once, not ever, in the entire observable history of the universe. This one-way arrow is so consistent that physicists sometimes call it the only law of nature that seems to actually care which direction time is moving. A footprint left in wet sand is a small, temporary monument to order. For a while, the grains hold a shape that has meaning, the unmistakable outline of a foot, a record that someone walked here. But wind moves a few grains. Water shifts a few more. Within hours, sometimes minutes, the shape that meant something is gone, scattered back into a featureless surface that means nothing in particular. Nobody destroyed the footprint maliciously. No one came along and erased it on purpose. The universe simply continued doing what it does by default. And the footprint, an unlikely arrangement maintained by nothing, lost the fight to stay unlikely. A photograph left on a windowsill fades. The chemical structures holding the image in place slowly break down under ultraviolet light, and the image, the face, the smile, the specific afternoon it preserved, dissolves into a uniform yellowish blank. A name carved into a gravestone, meant when it was carved to last essentially forever, is worn down letter by centuries of wind and rain, until what was once a name becomes a smooth, anonymous stone, indistinguishable from any other. A star, having spent billions of years converting hydrogen into heavier elements and radiating that energy outward as light and heat, eventually exhausts its fuel and cools into a dead, dark ember drifting through space, no longer doing anything especially interesting. None of these are acts of violence. There's no villain in this story. Physics does not hate memory. It simply does not preserve fragile patterns for free, and it never has, not once, anywhere we've looked. So if entropy is the default direction of everything, the quiet drift toward disorder, then life is strange. Life looks, on the surface, like a rebellion against that direction. A living body is an extraordinarily ordered thing. Organs in the right place, cells specialized into thousands of distinct types, a nervous system wiring sensation to reaction with breathtaking precision, all of it staying organized, hour after hour, year after year, against a universal current that's constantly trying to flatten everything into sameness. But it's not actually a violation of entropy's tendency. It's a loophole, and a temporary one. Living systems don't defeat entropy, they borrow against it. A body stays ordered by constantly taking in usable energy, food, sunlight, whatever the organism's particular strategy happens to be, and exporting disorder back out into the environment. As heat, as waste, as the simple fact that maintaining your body's temperature warms the room around you. You are not breaking the rules. You are running a very expensive, very temporary operation that keeps your local patch of the universe more ordered than its surroundings, financed entirely by energy flowing through you and out the other side. This is expensive in a way that's easy to underestimate. The brain, by weight, is one of the most energy-hungry organs in the human body, consuming a disproportionate share of your daily caloric intake just to keep its billions of connections active and its patterns intact. Every thought you have, every memory you retrieve, every moment of recognition when you see an old friend's face and know instantly who they are is paid for. Literally, chemically paid for, with energy that ultimately traces back, link by link, to sunlight striking a plant, or an animal that ate that plant, or another animal that ate that animal. You are not separate from that chain. You are the most recent, temporary, expensive link in it. We are not exceptions to entropy. We are structures riding an energy gradient for a while, the way a whirlpool exists for a while in a draining sink. An organized pattern that persists only as long as water keeps moving through it. Stop the flow and the whirlpool isn't preserved somewhere safe. It simply stops being a whirlpool. Because individual memory is so fragile, so dependent on a single biological system that eventually fails, humanity has spent its entire history trying to build something sturdier, something outside the body. We call this civilization, but underneath the architecture and the politics and the economics, a huge amount of what civilization actually is an external memory system. A way of recording things that matter so that the recording can outlive the individual brain that first held the thought. It started, as far as we can tell, with marks on cave walls, ochre and charcoal, hands pressed against stone and outlined in pigment, animals rendered with a precision that still startles people who see them in person. Someone wanted something remembered, and a wall lasts longer than a lifetime, so the wall became the memory. Then came writing, an extraordinary invention that let a thought be detached entirely from the person who had it, carried across distance, across generations, read by people the original thinker would never meet and couldn't have imagined. Libraries gathered these recorded thoughts together in one place, an attempt to build a memory too large and too important to be trusted to any single mind. Mathematics became its own kind of memory, a way of encoding patterns that seem to hold true regardless of who's doing the calculating, a record not of one civilization's particular beliefs, but of structures that appear to be built into reality itself. Photographs arrived and let us freeze a fraction of a second of light, exactly as it struck a surface at a particular instant, a kind of memory more literal and unforgiving than anything human storytelling had managed before. Then, radio signals, leaking outward from Earth in every direction since the early 20th century. An unintentional record of our presence broadcast at the speed of light to anyone or anything that might one day be listening. Then satellites, then digital storage, then servers, then a planet-spanning network holding more raw information than every human memory combined, accessible in seconds from almost anywhere. It can feel, looking at all of this, like we've finally solved the problem. Like we've built something permanent enough, distributed enough, redundant enough to finally escape the fate that claims a single human memory. A photograph can be copied infinitely. A digital file can exist in 1,000 places at once. Surely this is different. Surely this finally beats the tide. It doesn't. It just moves the tide further out. Paper burns, and historically an enormous amount of it has. The Library of Alexandria has become a kind of shorthand for catastrophic loss. But it's really just the most famous example of something that has happened repeatedly throughout history. Libraries destroyed by fire, by war, by simple neglect, entire bodies of knowledge reduced to fragments or vanished completely, known only because some other surviving text happened to mention that they once existed. Stone erodes, slower than paper, but it erodes, and inscriptions that once recorded the names and deeds of kings who believed themselves eternal are now, in many cases, smooth and unreadable, worn down by the same patient, indifferent weather that wears down everything else. Digital storage feels different because it feels abstract, intangible, somehow exempt from physical decay in a way that paper and stone aren't. It isn't. A hard drive is a physical object with a finite, measurable lifespan, magnetic patterns that degrade, mechanical parts that wear out. Servers require constant cooling, constant power, constant active maintenance from human institutions that have to choose, every single day, to keep paying for that maintenance. A server farm isn't a vault. It's more like a fire that has to be continuously fed, and the moment an institution stops feeding it, for any reason, bankruptcy, war, simple loss of interest, the data it held doesn't get gently archived somewhere safe. It goes dark. We've already lost things this way. Things that felt, at the time, completely secure. Entire formats of digital storage have become unreadable within a few decades, not because the data degraded, but because the machines that could read it stopped being made, and the knowledge of how to build new ones quietly evaporated. Languages disappear at a startling rate, taking with them entire ways of categorizing the world, entire bodies of oral history and knowledge that were never written down anywhere else, gone within a generation or two when the last fluent speakers die. The internet, which feels to most of us alive right now like the closest thing humanity has built to a permanent record, is not eternal. It is a vast, distributed, genuinely remarkable structure, and it is also entirely dependent on continuous electricity, continuous institutional will, and physical hardware that will, eventually, every piece of it, fail. Civilization is a fragile archive that has gotten extremely good at pretending to be permanent. And on the timescale of a single human life, that pretending mostly works. Buildings outlast the people who built them. Books outlast their authors. It's easy to live inside that illusion and never feel the seams. But step outside a single human lifetime, and the seams start to show. On human timescales, memory feels remarkably stable. A photograph from your grandparents' wedding still exists. A building from a century ago is often still standing. A language spoken 1,000 years ago, while different from the one spoken today, still has direct descendants you could trace a lineage to. It's easy, living entirely within this scale, to mistake stability for permanence. They are not the same thing. Widen the lens to cosmic time, and almost nothing we've discussed survives intact. Every star has a lifespan, our sun included. Right now, it sits in a relatively stable phase, fusing hydrogen into helium in a process that's kept it shining at roughly the same output for billions of years, which is frankly, the only reason any of us, has been possible at all. But that stability is not permanent. In a few billion years, as the sun exhausts the hydrogen in its core, it will begin to change, expanding into a much larger, much hotter star, and in doing so, it will render the inner solar system, Earth very much included, uninhabitable, long before it ever reaches that stage. Long before then, in fact, the slow increase in the sun's brightness, a gradual process already underway, will eventually boil away Earth's oceans entirely. This isn't speculation in the alarmist sense. It's about as well-established a prediction as anything in astrophysics, the natural endpoint of stellar evolution playing out exactly as it has for countless other stars we've observed at every stage of that same process. So whatever record humanity manages to build, whatever vast archive of memory and meaning and accumulated knowledge we construct, it has a hard ceiling. Not measured in centuries, but eventually, on a long enough timeline, measured against the lifespan of the star that makes any of this possible in the first place, and it gets larger and colder from there. Galaxies themselves are not static, eternal structures. They collide, merge, get pulled apart by gravitational interactions that play out over hundreds of millions of years. And the universe as a whole is expanding, a fact confirmed repeatedly through multiple independent lines of evidence. And that expansion appears to be accelerating, driven by something physicists call dark energy, a name that, if we're honest, mostly just labels our uncertainty rather than explaining it. What this acceleration means, over sufficiently long timescales, is genuinely strange to sit with. Distant galaxies are not just moving away from us. The space between us and them is stretching, and the rate of that stretching is increasing. Eventually, galaxies far enough away will be receding faster than light could ever cross the growing gap between us, which means their light, already extraordinarily old by the time it reaches us, will simply never arrive at all. They won't be destroyed. They'll just become permanently, physically unreachable, fading past a horizon that nothing, not light, not information, not memory, can cross back over. Even if humanity, or whatever humanity becomes, somehow survives for millions of years, finds a way to leave Earth, finds a way to outlast our own sun, the universe itself keeps moving in a direction that makes usable, accessible energy progressively harder to find. Stars keep burning out faster than new ones reliably form. The raw material for making new stars, hydrogen gas spread through galaxies, keeps getting locked up in old stellar remnants instead of recycled into anything new. The whole system, vast as it is running down, the way a held breath eventually has to be let out. Except this is happening on a timescale so long that comparing it to a human life is almost meaningless. And it's running down in exactly the direction entropy predicts, toward less structure, less difference, less of the kind of organized complexity that for one brief stretch of cosmic time learned how to remember. This is the point where we have to talk about where that running down eventually leads, because the destination has a name, and the name is heat death. It's an unfortunate name, honestly, because it sounds violent, and it isn't. There's no explosion at the end of this story, no dramatic final event. Heat death describes a state, not an action, a condition the universe drifts toward as differences flatten out and usable energy becomes harder and harder to access. In the broad thermodynamic picture, as currently understood, the universe trends toward a state of maximum entropy, where energy is spread as evenly as possible, where there are no significant temperature differences left to exploit, where nothing is hotter or colder than anything else nearby, and therefore nothing can do work in the precise physical sense of that word. No engines, no metabolism, no stars converting fuel into light, no structure capable of doing the kind of organized, ongoing activity that thought, or memory, or anything resembling life requires. It is not an ending with drama. It is an ending by exhaustion. The universe doesn't get destroyed. It just runs out of differences to use. The way a battery doesn't explode when it dies, it just stops being able to power anything, because the chemical gradient that let it do work in the first place has flattened out into uniformity. This is why being erased is the right phrase, and a more frightening one than being destroyed. Destruction implies an event, a moment, a before and after with a clear line between them. Erasure in this physical sense is something quieter and in some ways worse. It's not that someone or something comes along and deletes the record. It's that the physical conditions that ever allowed a record to exist, the gradients, the available energy, the structured differences a memory needs in order to be written and then maintained, slowly stop being available at all. Nothing hostile happens. The hostility, if you can even call it that, is the absence of the conditions for anything to happen. Now, I want to be careful here, because physics in the 21st century has gotten more complicated than the simple picture of heat death suggests, and the complications matter. There's a concept in physics central to quantum mechanics that information in a deep and technical sense cannot simply be destroyed. Not memory in the human sense, not the shape of a face or the sound of a specific laugh, but information in the strict physical sense, the complete specification of a system's quantum state. According to this principle, even processes that look, from the outside, like total annihilation, may actually preserve that underlying information somewhere, encoded in a form we may not currently know how to read. This becomes especially strange when you bring black holes into the conversation. For decades, physicists genuinely debated whether anything falling into a black hole simply ceased to exist, information and all, gone, with no trace left behind anywhere in the universe. This became known as the black hole information paradox, because it appeared to directly contradict that core quantum principle that information shouldn't be destructible. The debate intensified once physicists realized, through work originating with Stephen Hawking, that black holes aren't perfectly black after all. They slowly radiate energy, a faint glow now called Hawking radiation, and over almost incomprehensibly long timescales, that radiation can cause a black hole to lose mass and, eventually, evaporate away entirely. The question that paradox raised was simple to state and brutally hard to answer. If a black hole eventually evaporates completely, what happened to all the information that fell into it over its lifetime? Did it come back out, encoded somehow in that radiation, or was it genuinely lost? As far as current physics suggests, the leaning, supported by a body of theoretical work, including ideas like the holographic principle, which proposes that the information describing what falls into a black hole may somehow be encoded on its boundary rather than lost in its interior, is that information is preserved in some deeply abstract, almost unrecognizable sense. The math suggests it isn't simply deleted from the universe. But here is the distinction that matters most for everything we've been talking about tonight, and I want to say it as clearly as I can. Fundamental information may be preserved in some abstract physical sense, encoded in radiation so scrambled, so thermalized, so thoroughly randomized, that recovering anything recognizable from it would be, for all practical purposes, impossible. Not impossible because the information isn't technically there. Impossible because extracting a usable, meaningful pattern, the shape of a face, the content of a book, the structure of a memory, from that radiation would require reversing a process so chaotic that doing so would be indistinguishable, in any practical sense, from impossible. This is the key emotional point of this entire video. So let me state it directly. The universe may keep the information. It may not keep the meaning. There's a difference between a pattern existing, technically, somewhere, in some form, and a pattern being recoverable, readable, usable, by anything capable of reading it. A page of a burned book doesn't violate any law of physics. The atoms that made up the ink and paper are still out there, conserved, rearranged into smoke and ash and heat, scattered into the surrounding air. In the most literal physical sense, nothing was destroyed. But you cannot read the book anymore. The arrangement that made it readable, that made it mean something specific, is gone, even though the underlying matter and energy persist. This, on a vastly larger and stranger scale, Maybe something like what happens to everything we are and everything we've built as the universe moves toward heat death. The atoms don't disappear. The energy doesn't disappear, not in violation of any conservation law. But the arrangement, the structure, the thing that made any of it mean something, the part that was actually us, gets scrambled past any possibility of being meaningfully recovered. There's another idea worth mentioning here, carefully, because it's easy to misuse. In a universe that persists for long enough, vastly longer than its current age, some physicists have explored the theoretical possibility of something called Poincaré recurrence, the idea that given enough time, a system with a finite number of possible configurations will, purely by chance, eventually return to states extremely close to ones it occupied before. Applied loosely and speculatively to the universe as a whole, this raises a strange question. Could particular configurations of matter, even configurations resembling a brain, or a memory, or a person, recur, purely as a matter of statistical chance, somewhere in the unimaginably distant future? Maybe, in some highly speculative sense. But notice what this would actually be, if it happened. It would not be continuity. It would not be your memory returning the way a saved file might be reopened. It would be a fresh, isolated, statistically improbable arrangement that happened to resemble something from the past, with no causal thread connecting it to the original at all. This is closely related to a strange thought experiment physicists call a Boltzmann brain. The idea that, in a sufficiently old and sufficiently random universe, it could, in principle, become more statistically likely for a fully formed brain, complete with false memories of an entire life it never lived, to spontaneously fluctuate into existence out of randomness, than for an entire ordered universe like ours to form the conventional way. This is, by most physicists' own admission, a deeply weird and not fully resolved corner of cosmology, and not something we should treat as settled fact. But it's worth sitting with for a moment because of what it implies. A random recurrence of a pattern is not the same as a continuation of that pattern. A Boltzmann brain experiencing a vivid, detailed false memory of a childhood that never happened is not the same as a civilization actually remembering its own past. Physics, in its strangest corners, may allow patterns to reappear across the vastness of time. It offers no guarantee whatsoever that those patterns would mean anything when they did, or that they'd be connected, in any way that matters, to whatever came before. That is, if anything, a deeper kind of horror than simple ending. Not just that the record might be lost, but that something resembling it might reappear, hollow, disconnected, meaningless, with no thread back to what it's imitating. So where does this leave the idea we started with? That for a while, against tremendous odds, the universe produced something capable of holding a model of itself. This is genuinely worth pausing on, because it's easy to rush past it. A brain, a few pounds of organized matter, can hold something like an image of a galaxy millions of light years away, can do the work of compressing an almost incomprehensible amount of cosmic structure into a thought a person can hold, briefly, in their mind. A telescope can take ancient photons, light that left its source before the Earth existed, and turn them into usable data, numbers on a screen, a picture, an answer to a question someone, somewhere, decided to ask. A child, looking up at a clear night sky for the first time, can ask, with total sincerity, where the stars came from. And somewhere in that question is an entire chain of physical processes: stellar nucleosynthesis, planetary formation, biological evolution, neural development. That had to occur, in sequence across billions of years, just to produce a being capable of asking it. This is extraordinary. Whatever else is true about entropy and decay and the eventual cooling of everything, this part is not nothing. For a while, a brief while measured against the universe's full timeline, the universe became something that could ask what the universe was. But it was, and continues to be, temporary. Not metaphorically temporary, the way everything in a poem is temporary. physically, measurably, thermodynamically temporary, in exactly the same sense that a footprint in sand is temporary, just operating on a much grander, slower, more bewildering scale. There's one more piece of this worth sitting with before we come back down to something smaller and more personal, because it changes how you think about everything that's come before it. It's easy, hearing all of this laid out, to imagine entropy as some kind of enemy, a hostile force working specifically against memory, against life, against meaning. That's not quite right. And the more accurate picture is, in its own way, stranger. Entropy isn't targeting you. It isn't targeting memory at all. It's the most basic statistical tendency in the universe, the simple fact that there are overwhelmingly more ways for things to be disordered than ordered. And so, given enough time and no outside intervention, systems drift toward the more probable, more disordered state. Not because anything is pushing them there, but because that's simply where the odds lead. What this means is that life, and memory, and thought aren't really fighting entropy in some dramatic cosmic battle. They're closer to a brief, local, energy-financed exception to a rule that holds everywhere else. A whirlpool in a draining sink isn't defeating the drain. It's just a temporary pattern that exists because water happens to be moving through that particular point in space, organized for as long as the flow continues, and gone instantly, the moment it stops. You and everyone you've ever loved, and every civilization that has ever existed, are whirlpools. Genuinely organized, genuinely real, genuinely capable of doing things that scattered, disorganized matter cannot do. And entirely dependent the entire time on energy continuing to flow through you, from a star that won't burn forever, in a universe that is, overall, slowly running out of usable differences to exploit. This is, I think, part of what makes consciousness specifically so strange to think about in physical terms. Not because it's magical or exempt from these processes, but because of what it costs and what it does with that cost. A rock doesn't need energy to remain a rock. It just sits there, stable, unbothered, requiring nothing from its environment to continue existing in roughly the same form for a very long time. A brain is the opposite kind of object entirely. It requires a continuous, uninterrupted, fairly enormous supply of energy every second, with no exceptions, or the pattern that makes it a functioning brain at all begins to collapse within minutes. Consciousness, whatever it ultimately turns out to be at the deepest level, is not a free, stable, low-cost feature of the universe. It is one of the most expensive things matter has ever learned how to do. And what does that expensive, fragile, energy-hungry process actually produce when it's running? Among other things, it produces something resembling a model. Not a perfect one, not even close, but a genuinely functional compressed representation of an outside world, built from sensory input and memory and inference, good enough that a creature carrying that model around inside its skull can predict, plan, recognize, and, in our particular and apparently rare case, ask questions about the very system that produced it in the first place. Think about what's actually happening when you look up at a clear night sky and feel something close to awe, light that has been traveling, in many cases, for thousands or millions of years, finally reaches a small, wet, electrochemical organ that took billions of years of evolution to assemble, and that organ, briefly, manages to build something like an internal representation of the very process that made it possible. A few pounds of organized matter, itself built from elements forged in the stars it's now looking at, momentarily holding something like an image of the universe that produced it. That's not nothing. Whatever else is true about decay and erasure and the eventual cooling of everything, that specific event, however brief, however local, however soon forgotten, is one of the strangest and most genuinely remarkable things matter has ever been observed doing anywhere. It's worth being honest here about what we're not claiming, because it would be easy to let this slide into something it isn't. We are not saying the universe built brains on purpose, the way someone might build a sensor specifically to gather information. There's no evidence for that kind of intention anywhere in the physical record, and claiming otherwise would mean abandoning the careful, evidence-based approach this entire video has been trying to hold on to. What we can say, much more modestly, is that under the right conditions that appear to be genuinely rare even across a universe of unimaginable size, matter, capable of modeling its surroundings, emerge through entirely ordinary physical and evolutionary processes. The same kind of processes responsible for everything else we've discussed tonight. No different in kind from stellar fusion or chemical bonding or the formation of crystals. Just far less common and far more fragile once it exists. That fragility is the part that matters most for where this video has been heading. A star, once it forms, can burn in relative stability for billions of years without needing to do anything in particular to maintain itself. A brain, by contrast, is in a constant, ongoing struggle just to remain itself for a single human lifetime, a few decades against a backdrop of cosmic time so vast that a human life barely registers as a flicker. The very thing that makes consciousness extraordinary, its ability to compress, model, and remember the universe around it, is also exactly what makes it so vulnerable, so dependent, so temporary, compared to almost everything else physics has produced. For a while then, against odds that are genuinely difficult to overstate, the universe became something that could ask what the universe was. Not metaphorically, literally, physically, through a process that can be traced, step by step, back through evolutionary biology, through planetary chemistry, through stellar nucleosynthesis, all the way back to the earliest moments after the Big Bang, when none of this, no stars, no planets, no chemistry capable of supporting anything like memory, yet existed at all. That fact alone, separate from everything we've said about decay and erasure, deserves to be treated as remarkable rather than ordinary. It's easy to take it for granted simply because it's the only condition any of us has ever personally known. The way someone born and raised entirely indoors might never quite grasp how strange weather actually is. But step back far enough, and the existence of anything capable of asking the question you're listening to a video about right now starts to look less like a default feature of reality and more like an exception, a brief, costly, statistically improbable exception, carved out temporarily against a universe that is, on the whole, trending in exactly the opposite direction. You've probably heard the comforting version of this idea before, somewhere. The phrase that gets repeated, in one form or another, across science documentaries and philosophy videos and quiet conversations late at night. You are the universe experiencing itself. It's a beautiful sentence. It has real philosophical lineage behind it, going back centuries, and there's something to it, in a poetic sense, in the way it dissolves the false boundary between you and everything around you, in the way it reframes a moment of awe under a dark sky as something less lonely than it first feels. But experience, on its own, without memory, without some structure capable of holding on to what happened after the moment passes, vanishes the instant it occurs. A universe that experiences itself for a fleeting instant and then forgets entirely isn't so different, in the end, from a universe that never experienced anything at all. The comforting question, can the universe experience itself, isn't really the dangerous one. The dangerous question, the one underneath everything we've covered tonight, is whether it can remember anything it experienced, whether any of it sticks, whether any of it survives long enough to matter to anything else, ever again. That's the darker turn this video has been building toward. Not whether there's a kind of cosmic experience happening through us, briefly here and there, scattered across an unimaginably large and mostly empty universe. Maybe there is, in some sense. But experience that leaves no lasting trace is closer to nothing than to something. And as far as current physics suggests, lasting traces are exactly what entropy is, patiently, relentlessly working against. So let's come back down, back to something closer to human size, because that's ultimately where this question actually lives, for you, specifically, tonight. Think again about someone you loved, who isn't here anymore, or who is far away, or who has changed enough that the person you remember doesn't quite exist in the same form anymore. Think about what's actually left. A photograph maybe, paper or pixels holding a frozen fraction of a second of light that bounced off their face once, years ago. A voice recording, if you're lucky enough to have one, a voicemail you never deleted, a video where you can hear them say something ordinary, something that wasn't supposed to matter at the time and now matters enormously. A name, which is really just a sound, a specific pattern of air pressure that you can still make with your own mouth, that calls up, instantly and involuntarily, an entire constellation of memory every time you hear it. Every one of these is a fragile physical trace, not a window into the past, not a connection that bypasses physics, a trace, chemical or magnetic or biological, arranged in a way that, for now, still does the work of meaning something, of calling something back. And every one of them is decaying at different rates, through different mechanisms, but decaying the same way everything we've talked about tonight decays. The photograph yellows. The recording's file format will, someday, become unreadable without active, deliberate effort to preserve it. The neurons holding your version of their voice will, eventually, when you die, stop firing entirely, and whatever specific configuration let you recall the exact pitch and rhythm of how they said your name will be gone, not stored somewhere safe, just gone. The structure that held it dismantled along with everything else. This is not meant to be cruel. I think it's actually the opposite. I think understanding this clearly is what makes the moment, the actual moment you're in, the photograph you still have, the voice you can still recall, mean more, not less. Because here's the thing about everything humans do that looks, on the surface, like an attempt at permanence. We write because we already know, somewhere, that we disappear. Nobody writes a letter, or builds a monument, or names a child after someone, believing that gesture will literally outlast the heat death of the universe. We do it anyway, because the alternative, doing nothing, leaving no trace at all, feels unbearable. We build because our bodies fail, predictably, on a schedule none of us chose, and something in us insists on leaving evidence that we were here regardless. We love fully, knowing the people we love will change, or leave, or die. Because time takes everything, eventually, and loving anyway is, in its own strange way, a refusal to let that fact be the only fact. We remember deliberately, effortfully, precisely because forgetting is the natural, default, energy-free direction, and remembering requires choosing, again and again, to spend energy fighting it. I think about this sometimes in ways that probably aren't unique to me, but feel personal anyway. The way these things always do. I remember being a kid, maybe 7 or 8, lying in a backyard somewhere on one of the rare clear nights where you could actually see something, away from enough streetlights that the stars weren't just the handful of brightest ones fighting through the glow. And I remember feeling 2 things at once, which I didn't have words for then and have only slowly found words for since. I felt unbelievably small, like the scale of what I was looking at made every problem I had, every small kid worry, genuinely, measurably insignificant. But underneath that smallness was something else, something closer to inclusion than insignificance. A strange, hard to articulate sense that whatever that was up there, I was somehow made of the same material as it. Not separate from it, watching from outside, but included in it somehow, however briefly, however small a part. I didn't know then about stellar nucleosynthesis, or entropy, or any of the physics that would later turn that childhood feeling into something I could actually explain. I just knew the feeling was real. And I think most people who've had a moment like that, lying outside somewhere dark enough, know exactly what I mean. Years later, I found an old voice recording, just a few seconds long, saved on a device I almost didn't bother charging up again. And hearing a voice I hadn't heard in exactly that way in years, did something strange to me. Not just emotionally, though it did that too. It made me suddenly sharply aware of what I was actually holding. Not a person, not even really a memory. In the full sense, a fragile physical trace, a specific arrangement of data on a chip that happened for now to still be readable, to still be capable of doing the work of calling someone back, briefly, into the room. I remember thinking, almost involuntarily, this won't last. Not because anything was wrong with the file, but because I understood, clearly, for maybe the first time, that nothing like this ever lasts. Not really, not in the way we want it to. And there's a smaller, quieter version of this thought I have sometimes living somewhere with enough light pollution that you mostly can't see the stars at all. Just a handful of the brightest points, washed out against an orange-grey sky. It's easy to forget, most nights, that they're even there in any meaningful sense. Easy to let the sky become just a backdrop, ambient, unimportant. But every atom in me came from up there, regardless of whether I can see it clearly on a given night. The connection doesn't depend on visibility. It was true on the clearest night of my childhood, and it's just as true on a hazy night where the only thing visible is a single planet, and maybe, if you're patient, one or two of the brightest stars. The city lights can hide the source. They can't change where the material actually came from. I don't share these because I think they're unusual. I think they're closer to universal than most of us admit out loud. This particular feeling of being made of something vast and ancient, while also being acutely, painfully aware of how temporary your own particular arrangement of that material actually is. So where does this leave us? At the end of an hour spent walking through entropy and heat death and information that may or may not survive its own scrambling. I don't think the honest answer is total nihilism, and I don't think that's just me softening the conclusion to make it easier to sit with. I think it's actually the more accurate reading of everything we've covered tonight. If we are, in some careful, physically grounded sense, the universe's temporary memory, then temporary doesn't have to mean worthless. In a lot of ways, it means the opposite. It means the moment you're in right now, this specific arrangement of matter and energy, capable of hearing these words and turning them into thought, capable of remembering someone, capable of looking up and feeling small and included at the same time, is not diminished by being temporary. It's made more intense by it. Scarcity is not the enemy of meaning. In a strange way, scarcity is one of the only things that has ever reliably produced meaning, in any system, anywhere. Physics may, eventually, on a timescale almost too large to meaningfully picture, erase the usable record of everything we are and everything we've built. The stars will burn out. The information, even if it persists in some deep, abstract, scrambled sense, may never again be recoverable as anything resembling a face, a memory, a name, a song. That part of the story is not optimistic, and I'm not going to pretend otherwise just to end on an easier note. But for now, the record exists. For now, after roughly 14 billion years of cosmic history, after stars lived and died specifically to make the atoms now sitting in your bones, and mine. For now, the universe has something capable of looking back at itself and asking what it is. For now, it has questions, actual questions, asked by things made of its own oldest material. For now, in whatever limited, temporary, physically fragile sense the word applies, it remembers through us, through the photographs and the voice recordings and the names carved into stone and the equations written on chalkboards and the quiet private memory of someone's laugh that you're carrying around right now, whether or not you were thinking about it before tonight. And maybe that's the most fragile and the most genuinely strange miracle available to us. Not that we'll last forever. We won't, and on some level, we've probably always known that. But that for this one stretch of cosmic time, against odds that are difficult to even calculate honestly, something exists that can notice the universe at all, before the noticing, like everything else, eventually fades.